Okay, hello everyone. This is the Squire Defiant that I took apart in my previous video. I was going to, as I explained in that one, put a perspex front cover on it and make it all look pretty and such like. It's not as easy as I thought. So, first thing to note, this unit is pre-assembled and is held together by some rivets, one just at the top here, one on the side and one on the other side. So dismantling it is actually quite complex. Would involve quite a bit of destructive drilling, which I don't particularly want to do. Secondly, because the bolt mechanism is double-sided, even if you put a perspex front cover on, you wouldn't see any of the levers move because they all sit inside there. So what I thought I'd do is I'd have a quick chat about what the patent says is new and novel about these, and about this padlock specifically, and then I show you the assembly of it and how the fourth lever works, or what they call the guard lever in the patent. So I'll go across a couple of things that the patent identifies that's just quick and easy. The first one is the actual shackle hinge pin. Now, if you've got a Squire Old English, the pin is exactly the same as the other rivets. It's just a rivet that goes through and is pinned over at the end. That's the same for pretty much anything else. I've got a union here. It's the same thing. I think it's a rivet that goes through and it's pinned over. I've got a few others dotted around up here that are all very similar. The problem with rivets are that they have to be quite soft, because otherwise how do you paint the end over? So the patent says that the idea of using this double thickness, this double diameter pin that's held between the two ears, so in this case it would be held between that hole there and that hole on the back. The idea that it's free floating and just held in place means that you can make it, or they can make it, out of hardened steel, which means you can't drill it, or not very easily drill it, especially with the rounded ends. So that's one of the things that they identify in the patent as a key aspect of this. Alongside that is the fact that holding together the whole unit, they've put two of the rivets, and these extra ones at the top here, up near the ears. So bending those ears back, as I found while I was trying to take this apart, very, very difficult. So that's point one. Hardened shackle hinge, which now doesn't want to go back in. There we are. Other way around. There we are. Lovely. Out of interest, the key cover is actually part of the patent. The way it's held in there by two rivets and a plate across the back, held in place on the front plate as opposed to the back front plate, that's part of the patent. So it's in there, it's novel, and I don't think I've ever seen it held, a cover held in this way in anything else. So again, patented keyhole cover. Why not, I suppose, if you're going to put it in place. Now comes the important bit. The important bit fundamentally in the patent is this double bitted, this double notched shackle. And the idea of this is twofold. Firstly, it's to make sure that the amount of material that's left after you've cut the notch out is greater than half of the thickness of the shackle. Okay? So what they're aiming to do is to not weaken the shackle by putting that notch in. Now you'll find in a lot of others, take this one here, you're way over half the depth. So that's a weak point. You also get other designs, obviously, with holes through, but again, you're weakening the shackle. So the idea is that having two of them, they can be smaller, and therefore the material left is much greater. The other point they make is that this is steel, very high shear strength. that means that the first thing actually that will go is the bolt if you try and force it, because it's made of brass. So in this case, what they've done, by putting 2 points on, they've halved the force that's applied on the brass bolt. So what you've now got is the brass bolt is no longer as weak point as it was in the past, because you're halving the force on it. So that's the whole basis behind the patent and this design. It has a little flaw which they obviously picked up when they did it, and the flaw is, and I'll do some stills later, so you'll probably find me overlaying some stills on this along with some pictures from the patent, which is a fascinating read if you're into geeky lawyer stuff. What they noticed was that there goes the bolt. And you could put the bolt part way down, and it would lock in place on the first notch, and you wouldn't be able to tell. You pull it back up, it's stuck. But as you can see, it's a tiny little nubbin that's caught there. That's not good. Obviously shear strength, all the other fun and games, straight out of the water. You're into a brute force attack here, you can just pull that bolt open. That's shackle open. So, obviously what you need to do is make sure the whole thing goes down, engages fully, and then the bolt comes across. So, this is where the fancy mechanism comes in place. First off, you've got your bolt fixtures, back plate. That allows the levers to sit in place and engage on the pin in the centre. What I'm now going to do, I'll pause it for a second while I fiddle this in, because it's an absolute sod to get in place. To ensure that the shackle is all the way down, they use the guard lever. Now the guard lever is set upside down, so the shackles and the levers are normally this way up, spring to the top, force downwards. Guard lever sprung from the bottom, forced upwards. What that means is that central pin gets caught. Until that guard lever is pushed down, it can't move fully across. So let me set this up and we'll come back to it in a second. Okay, we're back again. So in this case I've just got the guard lever free floating, because if you've got the other levers in place, one, it's difficult to see, and two, you need a key to move it. So what's going to happen here is, if I can get it in the right place on the video, there we are, lovely. As the shackle comes down, it makes contact with the top of the guard lever. If you try to lock it at this point, it would slide across, but it wouldn't engage. It doesn't go far enough across. I'm putting some force on it there. It doesn't go far enough across to engage with the shackle. So you can't accidentally lock it just on that first cut. What you need to do is push down on the guard lever, which then allows the whole unit to go across because it's gone past that gate. That now has you locked in place on both cuts on the shackle and both nubs on the bolt. So that's what the guard lever is there for, the fourth lever. It's specifically designed to make sure that that shackle is fully engaged before you lock it. If you don't have it fully engaged, reset it again because it's moved. If you don't have it fully engaged, firstly your bolt won't go all the way across, and secondly you won't be able to get your key out. So it tells you that you can't lock it because you haven't pushed that shackle all the way down to get it all the way across. Now engaged. One of the other interesting things for the shackle shape, which again is identified in the patent, is the fact that it curves back on itself. If you try and force the shackle out, brute force attack, Because of the angles of all of these, what happens is it actually drags the bolt tighter. So again, something else the patent identifies, dragging the bolt. As you try and force that shackle out, the bolt is actually forced tighter up against the unit, and that's all to do with the angles that are set up in here. So that's the internals of the Squire Defiant. I might try and put a perspex cover on the back, because actually that's probably the only place you'll see it. I also need to make myself a key, and at that point I can probably show you it working. But I think I've covered all the interesting points out the patent. I'll put this all together as a video with some pretty stills and some overarching pictures from the patent, and hopefully that'll be of interest. And when I've got it up and running with a key, which will be sometime hopefully soon, we'll give it a go on camera. Thank you very much. All the best.